Today we're going to be covering branching. We'll have a brief view of code blocks, which are blocks of code which will be branched around, branched into various things. When you get a block, then you'll get variables inside the block versus outside the block, and which ones can see which ones. Of course, we have the if branching statement, which does the branching, the else clause, which is part of the if statement, or it can be left off, a nested if. Then we have your chained else if, which is a sort of nested if, where we have if expression, else if, else if, else if, where you can test a number of different expressions. And the expression in the if statement that's being tested. Another type of branch is a switch statement, which gives you a multiple choice. It's like the else if, but with different type of conditions. The conditional statement, or the ternary operator, which we've seen a little bit of that before. And although it's considered evil, it is something that we need to talk about because you will see it in different people's code, is the goto statement. All right, now code blocks. We've already seen one type of code block where you've got your main function, where you put the entire program inside of a code block. Basically, you have your open brace, your open curly brace, which begins a block of code, and your end curly brace, which ends a block of code. Now, you can use a block of code almost anywhere and for any reason. Generally, you want to keep it as readable as you can. There are many cases where you might have a single line of code. It makes more sense to have a block of code there. And of course, a function such as main, you are required syntactically to have a block of code. Now, inside a block of code, your variables have scope, which means they can see everything inside that block of code. They can't see anything outside. Well, nothing outside can see inside the block. It's a way of encapsulating your code from the rest of your code. So the code cannot see variables in other blocks. So here's an example. Here we have the global area, which is outside of everything. And we've defined a variable, global var, equal to 17. Here's block A beginning, which stretches to here. And here's block B, which stretches from there. So inside block A, we've got integer block A is equal to 5 times the global var. So that'll be 17 times 5, whatever that adds up to. I'm not going to work it out. Inside this block, we have another block, block A1, which can also see block A, and it can see the global variable. And then we have block A2, which is also inside block A. And it can see the block A variable. It's global to block A, but not global to the program. And the global var, which is actually global to the entire program, but it cannot see block A1's variable. That's in a different block. Same thing here with block B. You can set the global var because you can see it. You have access. You can read to it. You can write to it. You can go both directions. You can set it to your block B plus 5, but you can't do anything with this variable, block A2, which comes from inside the other block. And so this is more important when you have functions and various other things where you're actually dividing your program into different files, into different pieces, and handing them out to different programmers to do different things. One programmer is working on this program, this one piece of the program, he doesn't want his other programmer to change his pieces. So this gives you a little bit more control over the full application. Now, finally, we get into our if statement. It tests an expression for truth. It does a little Boolean arithmetic on it. If the expression is true, then it goes into the if section. Here we have the if section is inside this code block. So here we just get a number from the user. He says, just type a number, you put a number in there, and it'll say, see out, you entered this number. If the number you entered is greater than, it'll do a test here. 52. 52 greater than 50, that's true. If it's true, this code block is run. 52 is too large, so we shrink it. We just subtract 25 from the number. And then we print out it's a good number. If you put in 49 greater than 50, well, that's false. So we'll skip over this code block. This code will not be executed. Else clause. The code is executed if the if expression evaluates to false. And if you put an else onto the if, it will go into the else portion. So here we have, if the age is less than 65, you don't get a senior citizen discount. But if you're 65 or older, this will evaluate to false, so you'll go down into the else clause. It says you qualify for a senior citizen discount, and we set the flag equal to true. Now note that every else has to be attached to an if. You can't just put an else out in the middle of the code. It has to be an associated if statement. Because that's the way it works. If the value is true, then the if block is executed. If it's false, then you go into the else block. Now, of course, one of the things that blocks gives you is the ability to nest your code. You can put an if with a block. Inside the block, you can have another if. Inside that block, you can have still more ifs. So we have if this expression A is true, we can perform some code. And then we have a nested if statement. We do another subblock. When that gets finished, we have more code for A. If expression A is false, then we come down to this else section, and we have another if for expression B1 inside of the else portion of this if statement. So you can branch these off as often as you like. It's as complicated as your application needs to be. You make sure your each else is properly matched up with the correct if. Here we see a whole bunch of nested ifs and nested elses. So this else belongs to that if. This else belongs to that if. This else belongs to that if. This one to that one. And this one to that one. As you can see, this can get complicated very quickly. And especially when you have a case where, what if there is no else for this particular if? But you put else that you intended to go to some other if. Well, the else will go to the nearest non-else if, to put it in the craziest way possible. So there will be occasions where you will need to put curly braces around the code so that you know exactly where a given else belongs to. So this is if without using blocks. It can be dangerous. So we got elses and ifs, and at least one of these elses is going to the wrong if. There are braces necessary, and I'm not even going to look at it to figure out where the braces go. But the indentation would lead you to believe that the else belongs to a particular if, and it's in there wrong. And I left that in there so that you can look at it and try to figure out, you scratch your head and say, how does this belong correctly if I indent it correctly? Now, part of nesting your if statements and nesting your elses, you have the else if. You have a chained if. It's not really a language construct, but rather it's a result of how the language works. So you have if age is less than 4, and print out it's a baby. If it's not less than 4, that is equal to or greater than 4. So we go into the else. The else, we have another if the age is less than 12, and we print out he's a toddler. Else if age is less than 18 is a teenager. Else if 65 is an adult, and a senior citizen. So we just else if, and it will just keep marching down each one of these expressions until it finds one that evaluates the true. And then after that, it won't need to go any further. Now, a little something about that expression that's in the if that is tested. It is a Boolean expression. It has to come up to a Boolean value. It has to be evaluated to true, or it has to be evaluated to false. The language requires that you put it in parentheses. You can put in extra parentheses if you want. It doesn't matter, but you need at least the one parentheses. Most frequently it's used in making a comparison. You won't see very many complicated Boolean expressions in here. Sometimes you do, but usually it's just like, if A is greater than or equal to B, then we go do something. Now, one of the things inherited from C, it's not, Boolean can be loosely defined. And basically, if it's 0, if it evaluates to a 0, it will be considered false. If it evaluates to anything else, like -1, it will be considered true. That can be confusing. It does have its uses here and there, but for the most part, you want to stick with Boolean values. Now, a little note about style. When you try to make your code readable to a human. Now, it's great and everything when the compiler can read it and compile your code and it works perfectly. That's great. At some point, someone's going to have to look at your code and say, it's not working right. What do I fix? And so you have to have a style. Like always, we pick a style, stick with it, remain consistent throughout the code. If you're working at a company that says, we write our code like this, you do it the way the company says. One style is the curly brace is opened on the same line as the expression. Another style, the curly brace is opened up on a new line. Sometimes it will open up on a new line and indent the brace, and the code and the brace will be indented the same. It doesn't matter. There's other styles. These are just 3 common ones. Pick one, stick with it, write all your code so that it all pretty much looks the same, and that way it'll be easier for somebody else to read, make changes, fix things, add features, etc. Same thing with the else clause. Here we have the brace that's closing the previous if brace, and the opening brace is on the same line. So we have brace, else, brace, all on the same line. That's one style. Another style, close up the if, put the else on a line by itself, open up a new one. Here's the third style. Close up the if, and do else open brace on a line by itself. Again, style is a matter of personal choice. Pick a style, stick with it, remain consistent. You'll make your code easier for someone else to pick up and read. Now we have the switch multiple choice, which is like an if, else if, but requires an integer. It will take that integer and evaluate it, and then branch into whichever case statement matches the integer value. So the syntax basically is switch, your parentheses, your variable, close, open your brace, and then your switch is closed with a closed brace. And you have these numbered labels for where it will branch to based on the value of this variable or expression here. And your break command is very important because that's how it breaks out of this case down to after the switch statement. So basically you have case, the integer value, colon, your code, and then a break to get out of the switch statement. Like I say, it's equivalent to a chained if. If we had this statement here, switch choice, case 1, first option, break, case 2, second option, break, and in the event that this choice is not listed in any of the cases, there is a default label. So, you made an incorrect choice. This is the same as an if choice is equal to 1, to see out the first option, else if choice is equal to 2, the second option, otherwise print out incorrect choice. Which one you want to use depends on a number of factors. The switch statement only works with integers. There are occasions where you will get an integer back from a function call or from the user, and it's a very straightforward thing to break it out into pieces this way. Like this could be a function call. So you have a different function call based on which number is selected. There are other occasions where the if, else if makes more sense. So it's a judgment call which way to go. A few little tricks that you can do with a switch statement that you can't do as easily with an if, else if. You can leave the break out. So you have case 1, case 2, case 3 are all the same code. So rather than having case 1 code, case 2 the same code, case 3 the same code, you just put case 1, case 2, case 3, and then do the code for these 3 cases. These don't have to line up like this. You can have case 12, case 92, case 53, and then run some code that applies to those 3 cases. In this particular type of option, the switch statement can be a better choice because it's a little easier to lump all these cases together for the same code. Now, in terms of taking a break out, you can also put a break in where you don't need it. You don't need the break after the default. You've got your code, but you might want to put a break there just to make sure that it definitely will break out, but it does break out after the default. But the reason why you want to do that, you might want to say, well, that's not going to be the default anymore. I'm going to change that to case 9, for example, and then move it someplace else inside the switch statement. Well, you've already got the break there. You don't have to worry about adding it. Because if you forget the break, if you move it to case 9 without the break, it will fall through to the next case. You may not want that to happen. And now we have the conditional statement. We saw a little bit of this before. Uses the notorious ternary operator. So your first expression is evaluated. If it's true, then it returns the value in the second expression. If this is false, then it returns the value in the third expression. So, which is what we say here. So it works very much like an if and an else. Be careful with it in terms of readability. Don't just use it because you can use it. Most of the time you'll have an if else is more readable because people are expecting an if else. But there are occasions, there are circumstances where the ternary operator can be more readable. So don't use it as a substitute for if else. So this is not good. If A is greater than 7, then B equals 5. Otherwise, B equals 6. That's an if else. Don't do that. So what you want for that is if A is greater than 7, then execute B is equal to 5. Otherwise, execute B is equal to 6. Now, if you still want to use it, in this particular circumstance, there is a way to use it, and it is readable. You set B equal to the value. If A is greater than 7, the value you want to return is 5. Otherwise, is 6. And this is pretty much the style that's intended for the ternary operator. This is probably still, in most cases, better. But there are occasions when this is much more readable and it's easier and it's quicker code. So here's some examples here. We're going to calculate the answer. I'm not going to tell you how this answer happens to be calculated. We have a Boolean value that means there's an error status, and how we get this error, we're not going to say that. We just have a comment for that. So we want the answer that's going to be returned. We want to say, is there an error? If there's an error, Well, we're going to throw away the calculated answer, and we're going to return -1. That flags to the caller or to whoever that there was an error. Otherwise, if there is no error, this is false, return the calculated answer. This is like a certain circumstance where the calculated answer is unpredictable if an error occurs. But you want that to be predictable. You want the answer to be, in this case, -1 in the event of an error. So there we have the ternary operator handling that. So basically we're saying if there's an error, the answer will be -1. Otherwise, the answer is what we calculated. Another example, if your age is greater than or equal to 18, then what will be printed in the cout is the part after the question mark, you are old enough. Otherwise, the part after the colon, please ask your parents. And you can see this is marginally not a good way to do it. You might want to do this with an if-else instead. But you will see this style of doing things, particularly with output, rather frequently. Now, finally, we have go-to. Evil. Go-tos have a history of writing spaghetti code where we will go to this label if this is true, and if this is false, we will go to here, and then we'll go to there, and we'll go to there. You get your code. Now you've got me just displaying this over here like this is a sheet of paper. Multiply this by thousands and thousands and thousands of pages of code where your go-to can be to Chicago down there, and then go back to Los Angeles, and the go-to can be very, very, it makes it very difficult code. It's been labeled spaghetti code, and we want to avoid spaghetti code. The way it works, you can go to in and out of blocks. As long as you stay inside the function, you can just go anywhere inside the function. It's fairly dangerous as a branching mechanism because, I say, it can make very complicated code. C++ and all modern languages have got enough structured and object-oriented constructs that you almost never really need a go-to. There's possible occasions where go-to is your best solution. Most of the time, it is not. So just in case you need it, this is how it works. You say go-to and have an identifier. Then you have identifier and colon. Most of the time, there'll be an if statement around it someplace. You'll say if some expression, go to the identifier. Because otherwise, it's a why put a go to here? Just put the code there. So, or it could be inside of a loop, all sorts of various things. But we just basically are just mentioning this so that you know that it's there. But remember, it's evil. So don't use it unless you really need to. So a couple of do's and don'ts. Do watch spaghetti westerns. Don't write spaghetti code. And with that, we come to the close of another class. Thank you for watching educator.com, and we'll see you next time.